Hello everyone, this is Akash P. Banavar of Civil Engineering Department, Sri Venkateshwara College of Engineering. Today I am going to present a topic called Kinetic Roads under the guidance of Mr. Naveen Kumar BM, Assistant Professor, Department of Civil Engineering, Svce, Bangalore. Contents: Introduction, Objectives, Literature Review, Mechanism, Methodology, Applications, Advantages and Disadvantages, Case Study, Conclusion, References. Introduction. Nowadays, all the energy resources are depleting due to our constant dependency on natural resources. At this stage, an urgency has emerged to harness the energy that can operate almost anything in the world. Likewise, in the civil engineering world, new inventions are emerging to make a greener world. In the transportation sector, kinetic roads can help tackle pollution and our extensive dependency on natural resources. Solar radiation and kinetic energy from passing automobiles are two forms of energy sources frequently applied to road surfaces. As a result, they offer a lot of potential as long-term energy sources. Roadway pavement occupies a large portion of urban and rural areas, covering millions of square kilometers and constantly being exposed to various energy sources such as sun radiation, vibration, and traffic induced pressures. With these in mind, to collect energy from the pavement, two main technological groups are now being used: those based on heat or sun radiation, and those based on converting kinetic energy from moving traffic to electric energy. Both of these sources have demonstrated their ability to provide energy to transportation infrastructure. Objectives: to create electrical energy for running our appliances which are used in day to day activities, to utilize freely available renewable resources for generating energy rather than using exhaustible non renewable resources. Such ramps can be designed at every highway as an alternative source of energy to meet the increasing demand of energy. This energy can be used for the lights on the either sides of the roads, and thus much power that is consumed by these lights can be utilized to send power to these villages. Literature Review: Generating Power Every Time You Hit the Road by Rutger in 2018. This gives the review of available energy harvesting techniques that can be applied to roadways and bridges, making them a source of renewable energy and improving overall sustainability of infrastructure. The paper compared technologies in terms of power output, cost effectiveness, technology readiness level, advantages and disadvantages, support from government and industry. It posited that the energy harvested can be used to produce electricity, melt ice and snow, or power wireless sensors, lighting and signals, and devices to monitor structural conditions. Mechanism: energy generated by moving vehicle. Some of these technologies have been evaluated, and various prototypes based on piezoelectric and thermoelectric technologies are developed by investigators involved in this study. Earlier studies have shown the piezoelectric energy harvesting systems are reliable energy resources for lower power roads, including sensor and LED light research. Several prototypes have been developed in order to increase the power output, reduce floor deflections, and ensure prototype durability by modifying the prototype geometry and piezoelectric configuration. As we know, the vehicles on road are increasing very fastly in the world. As these vehicles are moving on the road, they possess some kinetic energy, which can be used for generating rotational motion of generator, and then we can produce considerable amount of electricity. As we know that the resource to generate the electricity are lasting very rapidly, and there is great increase in population which uses the energy crisis in the world. So we need to bring such ideas which can generate the electricity from the things which we can use in day-to-day life. So from the vehicles we can generate the electricity by using their kinetic energy as these vehicle passes on the ramp. The ramp was invented by Peter Hughes, an electrical and mechanical engineer who is employed in Highway Energy System Limited. This company says that under normal traffic conditions, the apparatus will produce 30 kilowatt of electricity. Other proposed applications for the road ramps include powering streets and traffic lights, heating roads in the winter to prevent ice from forming, and ventilating tunnels to reduce pollution. First of all, we need to know about the concept of this technique. If we want to use the kinetic energy, which is to be converted in electrical energy, we have to make a mechanical mechanism to rotate a generator, and kinetic energy will come from the vehicles of the road. The electricity produced from ramp is said to be clean because its production produces no pollution. As both health and environmental concerns are on the rise, clean energy sources area growing demand. We are proud to present the energy ramp, which is made to deploy on roads and that can produce electrical energy without any cost when a vehicle passes over it. This generated energy can be utilized for many purposes like street lights, lightings of signal, toll plaza, villages where the lack of electricity is more. The ramp is not like usual speed breaker. It is not harmful for the vehicles or cannot become the cause of waste petrol when a car passes over it. The speed ramp is not dangerous for vehicles at all. It does not only generate free energy, but the energy that has been generated is environment friendly with almost no pollution. On the whole, energy ramp system consists of two parts, hardware and software module. Methodology. This video shows us the working of the power ramp or kinetic ramp, which was manufactured in 1VE Energy System Limited by Peter Hughes.
A busy traffic scene in a town centre during daylight hours. At all times, electricity is required to power traffic lights and road signs, and in addition, at night, street lighting. All this consumes enormous quantities of expensive electricity. The electrokinetic energy road ramp is designed to generate electricity using kinetic energy from passing traffic. This energy, which is free, would otherwise be lost. The ramp achieves this by employing articulating plates that move up and down under the impact delivered by the vehicles. These plates are in turn connected to a mechanism that drives a specially developed flywheel that has a very low inertia from rest but is able to store a significant amount of kinetic energy. This in turn drives a generator with an electrical control which alters the magnetic field, enabling the mechanism to reach its maximum RPM. This is a prototype and is primarily to demonstrate the ability to produce electricity from passing vehicles. Designed for low-speed applications, this ramp outputs between 500 and 800 watts and adequately powers the light board connected to it. The ramp is of an advanced design resulting in an extremely efficient conversion of kinetic energy to electricity. In the production version, the ramp will deliver 5 to 10 kilowatts. Electricity generated by the ramp can be used for powering street lights, traffic lights, road signs and power for car parks. It can be used directly or stored in batteries. Any surplus fed to the national grid. Exhaustive tests have been carried out to establish that it poses no risks to vehicles passing over it. Unlike the speed hump, the ramp produces no discomfort to the car occupants. It can also be configured to produce compressed air for blowing pollution from tunnels. There are many other uses. The entire ramp will be hermetically sealed. It consumes no additional fuel, produces no emissions, and is environmentally friendly.
Methodology. The block diagram towards the left side shows us the components present in the kinetic ramp, and the block diagram at the right side shows the system process. Here the vehicle pushes and releases the ramp, then the linear push is converted into RPM, then the RPM is converted into DC volts, and then DC volts inverted to obtain AC volts. Components. These are the components present in the block diagram. PLC, a programmable logic controller, is an industrial computer control system that continuously monitors the state of input devices and makes decisions based upon a custom program to control the state of output devices. Alternator. An alternator is an electrical generator that converts mechanical energy to electrical energy in the form of alternating current. For reasons of cost and simplicity, most alternators use a rotating magnetic field with a stationary armature. Inverter. An inverter converts the DC voltage to an AC voltage. Proximity sensor. Proximity sensor includes all sensors that perform non-contact detection in comparison to sensors such as limit switches that detect objects by physically contacting them. Proximity sensors convert information on the movement or presence of the object into an electrical signal. PC-based HMI. The hardware or software through which an operator interacts with a controller. An HMI can range from a physical control panel with buttons and indicator lights to an industrial PC with a color graphics display running dedicated HMI software. Limit switch. A limit switch is an electromechanical device operated by a physical force applied to it by an object. Limit switches are used to detect the presence or absence of an object. Specifications. These are the drainage specifications for kinetic road ramp installation. The highway drainage is constructed according to IRC. Height. The height should be 1 to 1.2 meter below the subgrade. Slope. The slope should be 2 meter horizontal and 1 meter vertical. The ramp drainage height should be 1 meter. Slope should be according to the ground level. And these specifications are done by applications: street lighting, public transportation, traffic monitoring, power generation, sustainable infrastructure, public spaces. This idea can be implemented in the floors of crowded places as footpaths, railway platforms, etc. Advantages: generation of power without polluting the environment, simple construction, mature technology, and easy maintenance. No fuel transportation required. No consumption of any fossil fuel, which is non-renewable source of energy. No external source is needed for power generation. Energy scarcity is the main problem in our country, so this may solve the problem to some extent. Electricity generated from one vehicle around 8.175 watt, which can be used for various purposes. Energy produced from this ramp is pollution free and maintenance of ramp is more, so it can be used in toll plaza, street lights, etc. We can get 24/7 supply of electricity without harming and polluting the environment. Electrokinetic road ramp is the method of generating electricity by harnessing the kinetic energy of automobiles that drive over ramp. Disadvantages: it is not able to effectively handle the friction. The limitation of only large materials producing substantial energy. Insufficient energy creation as compared to other sources. High initial cost. The challenge of keeping the movement constant. The expense of harnessing the kinetic rods. Case study: electrokinetic road ramp at Sainsbury's supermarket in Gloucester, United Kingdom. A supermarket chain opened its first people-powered store in June 2009 using technology that captures energy from vehicles to power its checkouts. In a European first, Sainsbury installed the inversion at its new store in Gloucester. Energy will be captured every time a vehicle drives over kinetic road plates in the car park and then channeled back into the store. The kinetic road plates are expected to produce 30 kW per hour of green energy every hour, more than enough energy to power the store's checkouts. The system, pioneered for Sainsbury's by Peter Hughes of Highway Energy Systems, does not affect the car or fuel efficiency, and drivers feel no disturbance as they drive over the blades. Conclusion. In this way, many other techniques can be applied to utilize and harness the energy around us. Engineers need to think of innovative ideas to save the earth as well as to generate ideas that are robust, sturdy, and economical. Global energy demand has risen significantly due to the world's growing population and the growing need to meet human needs through sustainable means. Efforts are being made to modify the system, even though the problems are insurmountable. Private companies compete in this sector, but governments in developed countries have recently noticed the developments in converting traffic rush into electricity and are funding many projects. Hence, we need more innovative idea to save our planet. References. I have referred the following papers: Science India, Generating Electricity from Traffic; Rutgers, Generating Power Every Time You Hit the Road; Indiegogo, Kinetic Roadways, Moving Energy Forward; Fish.org, Developing Roads that can generate power from passing traffic; SlideShare, Road Power Generation; Mohammad Riza Golikania, Reza Nasaria, Syed Amit Tahamiya, Sara Lejeteb, Samir Desaukia, Arturo Montoya, Harvesting Kinetic Energy from Roadway Pavement through an Electromagnetic Speed Bump. Applied Energy 250 in 2009. Elsevier. Thank you. Please like my video and share my video.